In this video, we'll discuss annuities and mortgages. Now, an annuity is a sequence of payments made at regular intervals. Most commonly, most annuities occur on monthly payments. Now, the amount does not need to be equal, but most commonly it is. Now, there are certain kinds of loans that are paid at regular intervals and are equal for all payments, and those are called amortized loans. And so if you hear the word amortization, that's dealing with these types of loans. Now, what are some types of annuities that you will see most commonly? Well, for one, there's retirement. Think about as you get a full-time job and you're saving for your IRA, that is an annuity because once you reach that age, you're going to get a regular monthly payment for your retirement. Now, before that, you're going to likely have a home mortgage, and that's a monthly payment you're going to pay. Now, the mortgage component may maintain the same, but your escrow may change, which may make your mortgage overall for each month change slightly from year to year or even month to month, but it will be paid every month. Also, many people will get car loans, and that is often an amortized loan because it will be an equal payment every month for the duration of the loan. Now, when we need to calculate annuity payments, what we recognize is that the payment will equal whatever our total amount that we start with, whether that's the loan or an investment, times the interest rate divided by how many times we're computing payments per year. And that's divided by 1 minus the quantity 1 plus that interest divided by the computations raised to the negative computations times time. Now, time is in years. That's very important. So if you see something talking about like a car loan of a 60-month loan, remember that has to be converted to years. It's very, very important on how we calculate this. Now let's look at an example. Say that Tanya wants to buy a car that's $32,000. She can get a 60-month loan at 1.9% annual interest. What will the monthly payment be? And let's round that to the nearest cent. So we know that the total loan would be $32,000. The monthly payment, we don't know. That's what we're trying to calculate. So that's our unknown. Then we want the interest rate of 1.9%. So we write that as 19 thousandths. Now we look at our time. It says 60 months. But remember, time is written in years. So 60 months is equal to 5 years. Remember, months, just divide it by 12. That'll give you the number of years. And last thing is, how many times are we paying a year? We're paying in monthly payments. So that's 12 times a year. So we have all of our information. We have our formula. And now it's a matter of substitution. So we have 32,000 times the quantity 19 thousandths divided by 12. And then our denominator is 1 minus the quantity 1 plus 19 thousandths divided by 12. Raised to the negative 12 times 5. So we simplify our division right here, the 19 thousandths divided by 12, and I can do it in both cases here. Next, I can add 1 plus that division. I'm going to now, in the next step, I'm going to multiply my numerator, and I'm going to raise this one number to the negative 60th power. I can do those in two separate steps, so because they're in different parts of the division problem, I can handle them separately here. Last thing, I need to subtract. And now I'm going to divide, in this case, what I'll call my numerator by my denominator. And that'll give me 559 and 601 thousandths. Now remember, this is money. Money rounds to the nearest cent, or the nearest hundredth. So I'm going to look at my zero, say look to the right to the thousandth. That's a 1, so I'm going to maintain the 0. Thus, Tanya will have a monthly payment of $559.60. Now, we can also consider the idea of what are we really paying in interest? Because when you look at a monthly payment, it kind of makes the interest just disappear, that you can't tell what's interest and what's the actual payment on the object. So part of this is because the interest is not simple, and that's because it's embedded in that monthly payment. So a lot of times, companies like to do that because you don't necessarily think about the interest, but it's important to recognize how much are you really paying. If you want to know, the easiest way to calculate the total interest you pay is to take your monthly payment, multiply it by how many times you're paying a month, by how many years, and then subtract the original amount. So that's all these parts mean. My I is going to be that total interest I'm going to pay. A was that original amount of my loan or investment. Then I've got my monthly payments, my time in years, and then the number of payments each year. So let's go back to Tanya. We know, again, that it was a $32,000 loan, that we found that the payment was $559.60, and we don't know how much interest she's going to pay in total, but we do know it was a 60-month loan, which means 5 years, and that it was regular monthly payments, which was 12 times a year. So if I use that information to figure out the total interest here, I'll have the $559.60 times 12 times 5 minus the original amount, $32,000. Now notice right here the N times T, 12 times 5 is 60. So that's where that 60-month loan comes in. It's one of the ways you can consider what's happening in this case. But I want to multiply just like I would following order of operations. So $559.60 times 12 will give me $6,715.20. Multiply that by 5 is going to give me $33,576. And now I'm going to subtract the $32,000 to get $1,576. That means in a 5-year period that at that interest rate, Tanya will be paying to the interest to that loan company $1,576. Now let's put all of this together. Let's look at it as if you were paying a mortgage, because the mortgage is probably one of the most costly aspects of individual's life, but it's also one of your most important ones. So let's look and understand both how do we calculate that monthly payment as well as how much interest would be actually accrued over the life of the loan. So say that Freddie is purchasing a home, and after the down payment, Freddie takes out a loan for $195,000. It's a fairly common amount. The loan lasts for 30 years with an annual interest rate of 4.25%, and that's a fairly common rate around now. So let's first calculate how much the monthly payments will be, and then determine how much interest will be paid over the life of the mortgage. So let's start with this monthly payments. We know that we need the actual initial amount. We need, in this case, we're trying to determine how much will be the monthly, so we don't know that. Next, we got our interest rate of 4.25. So we write that as a decimal. We know that the time is going to be 30 years, and these are being paid monthly, which means 12 times a year. We go back to our payment formula and substitute in all the values we have. Now we start simplifying. I'm going to simplify the 425 10,000ths divided by 12 in both cases. Now I can add the 1 plus that division. Now, like before, I'm going to multiply the two numbers in my numerator, and I'm going to raise this to the negative 360 in my denominator. Now I can do my subtraction, and finally I can compute the payment by dividing. And this shows that Freddie will pay each month $959.29. And why is it 29? Well, if I look, that's 287 thousandths, but I want to round to the hundredth. The 7 tells me to round up, hence why it's 29 cents. Now that's the first part. The second part's about how much interest will Freddie pay. So when we're calculating that, we're going back to just like how we calculate the interest for Tanya in the previous example. Again, we need to know that original amount. We need to know the payment, which we just said calculated as $959.29. We need to know how much interest we're trying to determine, which is unknown. But we do know that it's occurring for 30 years, and these are monthly payments. So with this information, we can calculate our total interest. We're going to take our payment times how many times a year times the total number of years and subtract the initial amount. So $959.29 times 12 will give me $11,511.48. Multiply that by 30. Now look how much that becomes. $345,344.40. And now we're going to subtract that original amount, which means that in the case of a 30-year loan, Freddie accrued $150,344.40, which helps you understand why banks and loan companies want to give people 30-year loans. Think about that. Like over the life of that loan, just from one loan, the bank company will make $150,000 in interest, which is a huge amount of money.